Now let's write the code for demonstrating the scheduled executor service. Let's create this class. Let's call this as scheduled executor demo. We will create a task. Let's call this as probe task. It will implement the runnable interface. Let's override the run method, and run method is going to print a message. Let's say probing endpoint for updates. Let's create the main method. So we have scheduled executor service. Let's call this as service, and from the executors let's call the new scheduled thread pool. New scheduled thread pool. Let's have the number of threads as 1, and the scheduled executor service does offer a couple of methods in which we could schedule the threads to be executed. We will go ahead with the implementation, which is scheduled at fixed rate. So the idea is that this particular thread will be executed at a fixed rate after certain point of time. So the way to write this is service dot schedule at fixed rate. So we have the actual runnable, then the initial delay followed by the period, and then the time unit. So runnable is the runnable, initial delay is after how much time this execution will start. So let's say you could pause for 2 seconds, and then after 2 seconds, every 3 seconds this thread could be executed. So let's write it. So the runnable here is the probe task, and let's say the first delay that I want is of 1000 milliseconds, and I want this to run every 2000 milliseconds, and the time unit is going to be milliseconds. Now let's execute this and see how is the output like. So we are seeing that this thing is getting printed, probing endpoint for updates, and it will keep on printing this every 2 seconds, and it will keep on printing this probing endpoint for update till the time we shut down the executor service. So how can we do that? Let's stop this and write some code for the same. So the way to do this is we can call the await termination method on the service handle, this object, and supply certain time. So it will wait for the executor to be terminated in that time range, and if it's not terminated in that time range, it will call the shutdown method of the executor service, which is going to gracefully terminate the executor service. So let's write the code for same. So we will put this inside a try block, because await termination is going to throw an interrupted exception. Let's have the interrupted exception as well, and in the try block we can check service dot await termination. Let's give it a time of 5000 milliseconds, and the time unit is milliseconds. So if the time is more than 5000 milliseconds, we can call the shutdown method. So let's say shutdown now, else if it goes to the interrupted block, there as well we could call shutdown now. Let's increment this time to maybe 10 seconds, and now let's run the code and see its output. So you see, the delay that we had was of 2 seconds, that every 2 seconds this should be printed, and after printing it for 5 times, that is like 10 seconds, it got terminated on its own. So that is how we could terminate the scheduled executor. So of course this is a very crude and basic way of writing things. In real world, probably we could have this termination logic on certain condition, and when that condition is getting fulfilled, we can call the shutdown method and close the executor service. So as I told earlier that this is one of the methods which is provided by the scheduled executor service, I will suggest you that as part of exercise, you could try to go inside the scheduled executor service and explore the entire interface, as in what all different scheduling options are there. For example, we have a schedule, then we have this schedule method signature, then we have something called as scheduled at fixed rate that we implemented, then we have something which is called as schedule with fixed delay. So I think it will be a good exercise for you to go inside this class and learn about these methods. And the other thing is that we have called shutdown now. So what it means is that this is a strict guideline to the executor service that whatever you are doing, stop doing that and shut down the operations of the executor service. There is another method, however, which is called as shutdown. So shutdown is somewhat more graceful in nature, and the way it works is that it initiates an orderly shutdown in which previously submitted tasks are executed. So whatever is there inside your task queue, those will be executed, and only after that the executor service will be shut down. But once you call shutdown, then the new tasks won't be allowed to come inside the task queue. But in the case of shutdown now, all the actively executing tasks are also halted and stopped. So this is the basic difference. Now we will have a quick look to understand and visualize the internal workings of the scheduled executor service. So as we saw earlier that this thread pool is for the kind of tasks which we want to schedule in some manner. And the way this works is all the tasks are submitted in a task queue. But this queue is a delay queue. In the delay queue, tasks are not kept in sequential manner. We can understand this to be some sort of priority queue, where the priority is the time of execution. So if there are two tasks, for example task 0 is supposed to be run after 10 seconds from the current time, and task 1 is supposed to be run after 15 seconds of the current time, then in that case task 0 should come earlier as compared to the task 1 in the task queue. Likewise, if task 1 is supposed to be executed first before task 2, then it should be coming earlier in the task queue. So everything else remains the same other than the queue, which is a delay queue in the case of scheduled thread pool executor.